The main topic of this webinar is to discuss what I find people spending a lot of their time on the takeoff, and I question the value of that. So this may be even a little bit controversial or a little bit challenging some of the old school conceptions about estimating, because I find people spend up to 80% of their time doing the branch takeoff, measuring the branch circuits for the devices, the lighting, and the home runs. And I'm going to show you towards the end that this is typically less than 10% of the job. We're going to talk about some shortcuts for determining the length of the wiring for devices, fixtures, whether you do it in conduit or MC cable. And then we'll also talk about shortcuts for calculating your branch home runs. So we had a couple polls. Let me click down to that. Go ahead, Derek.
All right. So we sent out an email, I believe it was yesterday. We like to send out an email with some questions to kind of get some feedback from our attendees before the webinar so we can discuss kind of what everybody's feedback is or what they're up to with bidding or whatever the subject matter. So here we go. The first poll question is, how do you calculate most of your branch wiring lengths? And I think we offered two options. Go ahead, Brian.
Yeah, and pretty closely split. And I will, I'll put it out there right away that I was taught the old school method, what I call old school. You measured every circuit on the drawings, whether you're doing it manually with the electronic device or doing it with electronic takeoff. You measured every run, either the way it was shown in the drawings or the way you thought it was going to be actually installed. I've really changed my concept or my mindset on that over the years. And you'll see some of the reasons for that as we go through the webinar here today. Here's the next question.
All right. Question number 2. How do you do your branch home runs? I think this one we got a user input on the last one, but otherwise, go ahead, Brian.
Yeah, so you'll see over half of 2/3 of the people actually take off the home runs with the most likely location and routing for the home runs. Again, I'm going to show you a shortcut for that I would argue gives you at least as much accuracy and definitely saves a lot of time. The last option is probably the most sophisticated way to do it, but again, it's always a trade-off between doing things the long way and the short way. Does it get you any benefit? That's what you really have to measure. And on large jobs, sometimes you just don't have the time to do all of these calculations and manipulations and tedious parts of the takeoff. So let's see.
All right. What percentage of the total cost of a commercial building is represented by the branch wiring?
And this is really a key part of this pop-up webinar here today, because if a typical job is the branch wiring is a relatively small percentage of the job, and you can see very few people responded that it was. And I've run these calculations over and over again. And when I talk about branch wiring, I'm not talking about the devices. I'm just talking about the wiring, whether it's done in MC cable or whether it's done in pipe. And that typically turns out to be less than 10% of the job, even if you do it in pipe. So we'll look at some of those, an example of that here in a few minutes, but I want to show you my spin on this and what I find has worked over the years. For typical commercial jobs, now again, we have to define typical and not just, doesn't mean any kind of job. You can't look at a 10,000 square foot warehouse with 2 lights and 2 receptacles and use these kind of averages. But for a typical commercial building, offices, tenant improvements, schools, medical, etc., you're typically going to find that a 20-foot average per device per fixture is actually going to be on the conservative side. And I would say, if anything, you can go a little bit lower on fixtures, because typically fixtures are staying at the same elevation on the drawings, if you will. Every receptacle and switch you have to drop down to or come back up to the ceiling from. So typically receptacles and switches have a little bit longer length. But if you use a 20-foot average, again, in a typical situation, you're going to be fine. And here's what I mean by a typical situation. If you've ever been to any of my classes, this is the branch power drawing we do for the class. You can see it's got a big warehouse space. It's got a little more than half the building is branch power, and this is what it looks like after you count up all the devices. And now we do take off home runs for mechanical. This is a 60 amp home run. There's another 30 amp one down here at the bottom for the boiler. But other than that, we use averages for the receptacles. So here's how that works in EBM. And if you haven't seen this module in EBM, really would recommend you take a look at it. There's a module in EBM under fixtures and devices called branch or quick branch. So you get all the typical branch wiring device assemblies that you normally use. If you were in device assemblies, this one here, but the big difference is when you're in quick branch, you can include any of the wiring assemblies automatically with the device. So just a simple example here for a receptacle, you go to duplex, and you scroll down to 20 amp spec grade and a plastic plate. And then up at the top right here, you can pick the type of wiring assembly. If you're going to do it in pipe and conduit wire, you click the first button. If you're going to do it in MC cable, you click there. And then you've got all the different MC cable assemblies that are in the cable module. So I would just typically use 12.2 for most of it. And then you can use 20 feet, but you can change that as you go. So if you've got some areas with high ceilings, you want to get a little more fine-tuned about it, or you've got a bunch of receptacles clustered in the same area, you can lower that. But again, that 20-foot average is going to work pretty darn well 99% of the time. So you just hit takeoff here. Oh, didn't put the quantity in. You hit takeoff, and you'll see in the audit trail, it makes an entry for the regular device assembly. I'll just open that up real quick. So there's the device, goes from line or entry number 86 down to here, and then entry number 87 has the 20 feet for each of the 20 outlets. So you get the same materials, the same fittings, the same supports, etc. Now the same thing works with pipe, and the same thing works with fixtures. So in the fixture module, let's see, I got a fixture A here. Maybe I'm going to, instead of using a fixture whip here, I can come over to this tab that says conduit wire and cable. And again, I've got all the wiring modules. So a nice thing here might be if I wanted to use luminary cable instead of regular MC cable. And I put my length in here and my quantity here and hit takeoff. So again, that 20-foot average works pretty darn good for most commercial jobs, for lighting, for switches, for devices. So let me just take a quick pause to see if anybody wants to discuss that. Again, I was taught the old school method. You measured everything in the drawings. But again, after seeing, $5 million jobs and $50,000 jobs, the amount of time it takes to actually manually measure that pipe and wire from the drawings is just, doesn't get you any benefit.
Nope.
So before we go ahead.
I was just gonna say, yeah. Seems like everybody is paying attention and no questions right now.
Okay, so let's talk about home runs now. And this is a method I definitely did not create. Most of my estimating knowledge is, even though I've done a lot of firsthand estimating, most of the things, the little tips and tricks and the point of view I've arrived at over the years is based on input from literally thousands of estimators. I've seen people that go through enormous amount of detail to get to the result, and I've seen people who ignore most of the details, and then I see everybody else that's somewhere in the middle. So I've tried to filter that through the years and see what really is viable. The big advantage of computers is we can get the best of both worlds. We can use shortcuts and that kind of thing and still get a lot of the detail all the way down to the wire nuts and the one-hole straps. We don't lose that detail because the program picks up so much of that automatically. So here's the method I learned for doing home runs, because what really determines the average length of a home run? The average length of a home run is basically going to be determined by the number of circuits. So if you go to your panel schedules, I've got a little sample here. I'll zoom in a little bit. Now you can do power separate from lighting, or you can combine them all. It doesn't really matter. But what we're after here by looking at the panel schedules is the number of 20 amp circuits. So we ignore everything else here. We don't care about mechanical. We don't care about anything besides 20 amp circuits. We don't even care about the outside lighting because we're going to take that off separately. So we're basically looking for everything in the building that's on a 20 amp circuit. So since we have a branch power drawing and a branch or a fixture drawing on this job, I do the calculations separately, one for branch power, one for lighting. So what we do at this point, we look at the panel schedule and we count up all of the 20 amp circuits for power. If I zoom in a little bit here, you'll see there's general receptacles, there's copiers, printers, server, fire alarm, etc. So on these two panels, there's 30 circuits. So here's the formula we use here. See if I can get back to that part of my.
I do have a question, Brian. You may want to get to it later, though. It's how would you do quick branch with on-screen takeoff?
Good question. I'll have to come back and explain that. I don't have. I'll come back to that. Thanks.
Right.
Okay, so there it is. That's what I'm looking for. Okay. So we've already talked about using the 20 feet per fixture per device for the average length of a run. And I'll come back and tell you how you do that on screen takeoff. So on this particular job, the branch power has 30 circuits, 30 20 amp circuits. So if we figure an average home run, again, you can get a little more sophisticated about this, but it's going to probably average 3 circuits in a home run. Then if we have 30 circuits, we're going to need 10 home runs. 30 divided by 3 is 10. Then we need to come up with the average length of a home run. Again, some people want to actually, go to the place in the drawings where they figure the home runs are going to come from. But, once the job gets up into any size, you can start using averages with a lot of confidence and comfort. So on this job that I've got here, go back to the floor plan. I measured the width and height of the building. So one of the nice things in PlanSwift is a dimension tool. This building is about 110 feet wide. It's almost square. It's 109 feet the other direction. So if you take half of the longest one, you can figure that's your average home run. And then I round up. So half of 110 would be 55. So I rounded up to 60. So if you take 60 feet for every home run, you'd put that into EBM as 10 runs, a total of 600 feet. And here's how I would do that. So we'd simply go to wire and conduit, go to branch circuits. And there's actually a perfect saved assembly for that. If I come up to the top here and hit saved assemblies, we can go to EMT set screw steel stranded wire, 3/4 inch with 7 number 12s. That gives us our 3 circuits with neutrals and grounds. If you want to get fancy and use the calculator, you can. 60 times 10 equals, and paste, and then 10 home runs. I do one other little thing here. I add 1 J box for every home run. Another little truism that very experienced estimators have mentioned over the years is you really can't put too many J boxes into an estimate. If you go to saved assemblies here, we'll do a 4 square box and a blank cover. We'll put in 10 of them. And you can even put a little note here. Branch power home runs. And you hit takeoff. And there we go. Now, I probably shouldn't have done this on this job because I was going to use this job to give you some examples of how the numbers turn out. So let me actually remove those last couple of entries here. Starting here is where I think it was. Yep. Okay. Again, if you've been to any of my classes, this is the commercial job that we use in class. It's about 11,000 square feet. It's got site lighting and site utilities and feeders and the whole bit. So when I go to reports here, and go to job totals, here's the entire job under what it names as default. So this whole job with everything in it is about $189,451. Now what I did was I separately went back to the audit trail and I pulled out all the branch wiring to see what the cost of that was. Now again, we're just talking the MC cable. If we did the job in pipe, it would be a little higher number, but not drastically. If we go to branch wiring here, watch how small a number that is. That's with overhead and profit. We're talking less than $8,000 on a $190,000 job. So again, spending over half your time taking off, I'll show you the percentage for that in a minute, but it's an under 5%, doesn't make a lot of sense. Now, if I add in the home run calculations, the branch wiring, including the home runs, is still only about $12,500. So we flip back to that little example here. Oops, wrong way. So with MC cable, the wiring for the devices and the fixtures is only 4.2% of the job. If you do it in conduit, I'm sorry, if you do the home runs, which we calculated in conduit, it's still only 6.2% of the job. So they're pretty small numbers. And again, I'm using relatively high averages. So it really makes an argument for using some shortcuts here. Arguably, the bigger the job, the more that you can argue that the averages are a little more dependable. That's kind of one of the law of statistics, is the more observations, the more the larger the sample size, the higher your accuracy. Just like when they do any kind of a poll, the larger the sample size, the higher the accuracy. But again, I've seen these so many times over the years on small, medium, and large jobs that I know these numbers hold true. So if there aren't any questions, I think that's going to wrap it up. We do record these. I'll go ahead and turn it back over. Oh, the branch with OST. Let me see if I can at least explain that. So we have two programs we integrate with for electronic takeoff. With PlanSwift, it puts when you use branch, quick branch, it pulls the quantity in just like it does normally if you're doing it, if you're just inputting the quantities here. In on-screen takeoff, there's a little spreadsheet. It looks like the PlanSwift spreadsheet. I can't even bring it up here, I don't think. I'd have to show you this by actually deactivating PlanSwift and activating on-screen takeoff. But if you're familiar with on-screen takeoff, every time you bring your entries, your material, your quantities back into EBM, it brings them into a spreadsheet. There's a little checkbox down at the bottom that says use quick branch, and then it'll use whatever numbers you've selected on here for the type of wiring and the length of each assembly. So it comes into the on-screen takeoff spreadsheet, and maybe that's something we can follow up with you, give you a call and show you how that works. But you can still use the quick branch when you're doing on-screen takeoff. So I'm looking for somebody who just hit the raised hand. Give me a second here. Got a pretty long list of attendees.
I have another question too. After.
Okay, so I see Aaron Counter, go ahead with your question. I tried to activate your audio, Aaron. I don't know if it's working. If you're there, go ahead and ask your question. I guess maybe go ahead and type it in. Hey, Mr. Mark Kendalls, how you doing? How you doing?
Hey, Brian and Derek, how are you?
Hey, Mark.
Good.
Well, this is great information, and it's funny because it's coming right in line with a class that we're going to be running on Thursday about branch circuits and home runs. So I really actually want to borrow your recording and play it in our show because exactly what you said is exactly what we teach. Couple things I noticed. Now you said you take off one junction box for your home run. I'm assuming, was that 3 circuits or 6 circuits?
3 circuits, so, and there were 10 home runs, so I did 10 J boxes.
Okay. So normally if I do a home run, I'll do three junction boxes, but that's just the methodology, because I'll do 3 circuits and say we drop one in this room, one in that room. It's
Yeah,
no big
like
deal.
I said, you can't have too many J boxes.
No, you can't. And again, it's peanuts, because like you said, you're at 4 and 5% of the job. I'd rather have a couple extra junction boxes than not enough.
Right.
One thing that you really didn't touch on, but your home runs are only like 55, 60 feet. On some of the larger jobs, we have to start talking about derating when you start putting those 3 and 6 circuits together. So I just wanted to throw it out there, just as a reminder to your participants in here. Don't forget, when you start getting in those longer runs, 100, 125 feet, open up the spec books, because there will be requirements of anything over 100 feet. You have to derate, or you're going to have to upsize your wire, which you'll want to read the specs before you do this. But this quick branch is fantastic, and we're addicted to it.
Awesome.
Good. Appreciate that.
You,
Thank you, Mark. Let's see if we've got anybody else questions. Now, it looks maybe like Aaron typed his question in.
Yeah, there's quite a few questions that have popped in. Firstly, does this work for hospitals?
I would think so, absolutely. A hospital is really not a whole lot different. The materials are different. You have different types of devices, and but I would say for the spacing and all that, absolutely, that should work. I would put hospitals in the commercial category where these 20-foot averages and the home runs would work.
All right. Would you do the same for mech EQ branch? EQ.
Mechanical equipment,
Yeah.
only if it's 20 amp. Anything that's 30 amp and above, I would definitely measure the home run. To me, most of the mechanical is really like a mini feeder, whether it's a 30 amp, 60 amp, 100 amp, 200 amp mechanical item, that definitely needs to be measured. You got to pick up usually a safety switch and motor connection and the home run. So that's not where I would take shortcuts.
All right. And I think that's about it. Just a couple comments, like someone talking about giving this a try after the webinar, and the Aaron's hand raise was on accident.
Okay. Alrighty. We'll go ahead and sign off. I appreciate all the feedback and welcome any more questions or feedback. I think if I go back to the last page of the outline here, it tells you how to contact us.
Yeah, and you could go to our website at visioninfosoft.com and go to the support page and submit a web form there if you have any questions, or email support@visioninfosoft.com to have any follow-up questions answered by our support department. Otherwise, I think you see the social networks there again to follow us, and I think that's all for this webinar. So thank you all for joining us.
Thanks again.